Hi Year 10 and welcome back to your distance learning lessons. This week it's consolidation week, which means that we're taking a look at everything that we've learned so far since the lockdown began. We're going to start by looking at the EM spectrum and EM radiation and that portion of the waves topic. Now, what we've got in store for you this week is essentially a selection of different revision tactics and review topics, followed by some knowledge retrieval quizzes. Knowledge retrieval quizzes are about 10 questions in length, some multiple choice, some short answer questions that you'll complete by accessing the Microsoft Teams link that's in the web document on the OneDrive. While those knowledge retrieval quizzes are really helpful for you to kind of implement your knowledge and get a really good understanding of the gaps in your knowledge, I think sometimes they're also a little bit derivative of the fact that you don't get the opportunity to show off everything that you do actually know about the topic, because the question just might not suit what you actually do know or what you know the best. So instead of doing lots and lots and lots of these little quizzes, I've tried to break down your revision and consolidation this week into different sections that will hopefully help everybody learn something. We've got the quizzes, I've got mind maps, you've got your flashcards to create, and we're also going to have a go at this thing together called a goal-free task. Now, a goal-free task is essentially something where there is no fixed endpoint that I'm expecting you to get to. It's just essentially a way for you to see exactly everything that you know about a given topic or question or anything that I might ask you here. So there isn't an expectation on you of completing the exact same piece of work as everybody else. This is based on what you know, what you understand, and what you think is helpful. Now, actually, these goal-free tasks, if you've not done one before, can be a little bit tricky to get your head around. So what I'm going to do for you now is essentially I'm going to walk you through how we would approach something like a goal-free task. And that's not to say that I'm expecting everyone to have done everything on here. You might have thought of less that will go into your goal-free task. There might be more that you're expecting to go into a goal-free task. But I'm just trying to give you a sense of what kind of things that we would expect and how I would expect you to show off your knowledge on this certain topic. So I've got essentially a short statement here that we're going to base our goal-free task around. Note that it's not a question, it's not asking you about a specific mark, it's a simple statement of fact. It says that the electromagnetic spectrum is the range for all EM radiation, organised by wavelength, from the longest to the shortest, and frequency, from the lowest to the highest. So this is the point that I would start thinking, okay, what do I know about the electromagnetic spectrum? And if you think that you know what you might be asked to do here, then simply just pause the video and get on with it, okay? Essentially, this is your chance to throw everything that you know about the EM spectrum onto your sheets of paper in front of you. So you should have a sheet of paper and a pen or a pencil, something that you can take notes with at this point. And all the time you should be thinking about this statement about what the EM spectrum is. So again, if you think you know what you're being asked to do here, pause the video and just get on with it. Throw what you know at that piece of paper. If you think that you need a little bit more guidance, then that's what I'm going to do now. I'm essentially going to talk you through what I would be thinking in this instance, give you a set of clues as to what you might be putting down in your case. So, it's asking me about the EM spectrum. Straight away, what comes into my mind is that picture of what the EM spectrum looks like. Okay, so you'll have seen it in the textbooks or on your knowledge organiser as we've gone through this course so far in lockdown. EM spectrum, if you were to draw it out, looks something like this. So there's our long wavelengths. The wavelengths get shorter. And as the wavelengths get shorter, then also what happens is the frequency becomes larger until I'm left with something that looks like this. Okay, so that's what I would be expecting you to pop into your mind straight away. And I'm also just going to label some of the basic statements onto my picture of my EM spectrum. Okay, so I'm going to have wavelength, which remember give a symbol of lambda to. And that's going along the bottom. So if I draw some kind of axes on here, that way, and that's the longest to the shortest. And I'm also going to put another label at the top here. This is frequency, F. And it's also the lowest to the highest. Okay, so at the minute, all I've done is turn that information that's in the statement into a picture. Okay, how I would show this. Yeah, it's quite messy. Okay, so you could probably do better. You could probably have taken a little bit more care and drawn out your wavelengths in a lot more precision. But this is what I'm going to stick with so far. So, now that I've got this, some of the things are starting to pop into my mind. And that might be the case for you too. If you think that you can now go on from here and add a few more bits of information that you know about the EM spectrum, this is your opportunity to do so. So just pause the video and you can add any extra information. You can always come back and see what I've added and check your answer against what you've got as well. Okay, so now I'm going to start thinking about all of the different parts of radiation that are present in the EM spectrum. And I'm going to start at the left-hand side with the longest wavelength, which I know is radio. And then I know that moving from the longest wavelength and the lowest frequency all the way to the highest, I could add a couple of other labels onto here as well. So I've got radio, then next I have microwave, then infrared, then visible light, then ultraviolet, then X-ray, and then gamma. And it could be that you've got a really clever way of remembering those words, okay? So you could have come up with something like the kind of acronym for all of the different types of radiation there. It could be that you've just remembered them. It could be that you're looking at your notes currently while you're trying to do that, and that's fine as well, because there isn't really a goal, there isn't really a way for you to do this. You're just trying to show off all of the knowledge that you've got here. So now I've got all of the different types of radiation, it's starting to jog my memory a bit more, and I could maybe think of some uses, some dangers, and some ways in which these types of radiation are used and why they're used for what they're used for. That's a strange sentence for me to have said. Okay, so radio. Straight away, again, if you know what I'm about to do here, or if you think that you know what I'm about to do, this is where you pause the video and give it a go yourself. So, radio waves. Okay, apart from the fact that we use them to literally listen to radio on, I know that they're used for telecommunications and radio communications, so I'm just going to summarise that by saying that they're used for communications. Why are they used for communications? Well, they're used for communications because they're easy to generate and transmit due to their long wavelengths. Okay, so easy to generate and transmit due to long wavelengths. What I also know about radio waves, again, due to that long wavelength, it can't pass through the ionosphere. And remember, the ionosphere is that layer of atmosphere at the very utmost outer reaches of our Earth's atmosphere before our Earth's atmosphere turns into space. Radio wavelengths are reflected at that boundary, so they can't be used for satellite communications. Okay, so I should actually change communications here in my uses to TV and radio communications, because that would be really misleading of me to say that they're used for all communication when we know that they can't pass through the ionosphere, so they're not used in satellite. Okay. And then I also have thought about the fact that we've got dangers for all of these parts of the EM radiation, EM spectrum as well. Now, there's not a great deal of danger associated with radio waves, and indeed, actually, when you do find dangers that are associated with radio waves, it's usually not particularly well researched, okay? But there are some papers and some scientists who would claim that in large quantities or at high intensity, radio waves can damage cells, okay? So for very high intensity radio waves, and that's kind of on that bridge of the gap where radio waves becomes the microwave, okay? So that's the really high energy, the higher frequency radio waves, the shorter wavelength radio waves. At that point, that's when they could potentially cause damage to cells. Okay, so I've got that information down there. This again is where you can pause the video and start adding your own uses, dangers, and reasons for why those EM spectrum waves are used for their particular uses, if you can know and remember. I'm going to give a short, condensed version. By all means, you should definitely be thinking about the fact that there are way more that you could include in here. I'm not going to do it because I don't have the space, and I want you to have a go at this yourself. But you can think about the fact that there are loads of different things that you could use for each of this portion of the EM spectrum. Okay, so again, microwave, obviously, one of the things that's used for is cooking. Heats water molecules up inside food, and they start to vibrate and become energetic, and that's how food ends up cooking, because they've gained kinetic energy from the microwave, or from the absorption of the microwave. And as that kinetic energy increases, the thermal energy increases, so you get warm food. Obviously, you know that they could be potentially dangerous, and once again, there are numerous scientific papers that have described the fact that overuse of microwaves could potentially cause infertility or even cancer. Infrared. This is used for things like night vision. It's used in remote controls. Visible light. Okay, I'm going to spend a little bit more time on that one. I'm going to go up here with it just to give myself a little bit more room. Visible light, that's the portion of the EM spectrum in which we can see, so it's really important. It's actually a very short gap within the EM spectrum, so the wavelengths in which we can see are not very big compared to the rest of the spectrum. But this is how we can see. And this leads the way into you talking about so much other portions of our waves topic, if you wanted to give that a go as well, okay? So because we've got how we can see, you should be thinking about the visible light spectrum. And I would be thinking in that, we've got all of the colours of the rainbow, okay? So when light passes through a prism, it's split into its 7 different colours. Those 7 different colours correspond to different wavelengths and frequency. So we've got our red, orange, yellow, green, blue, and violet. Okay, so I'd be thinking about, sorry, we've also got indigo as well in there, okay. I'd be thinking about each of those colours and what that would mean. I could go on to talk about filters. And you could put more information in this section here, okay? So again, pause the video if you need to and expand on that section of visible light. Talk about filters, talk about colour, that kind of thing. Ultraviolet, that's obviously contained within the sun. We can use it for sterilising equipment. It's got numerous dangers though, remember. It can cause cataract, it can cause skin cancer, it can damage cells, it can cause sunburn, that kind of thing. So that's kind of what I'd be thinking about there as well. X-ray should be one that's most familiar with you. Some of you will have definitely had to have x-rays before. I know I certainly have. So this is obviously where you use it for medical imaging. Really, really useful. But remember that it's also incredibly ionizing, especially those of higher frequency, so towards the gamma ray portion of the EM spectrum. Those x-rays very rarely get used in medical imaging. They use the lower frequency x-rays for that. And remember that we've got to think about safety of people who use those x-rays. So for example, a doctor, when they take an x-ray of a broken foot, let's say, I'm using that as an example because that's the most recent x-ray that I had to have. When they take those x-rays, they typically will stand outside of the room and take those x-rays because they don't want to have continuous exposure to the ionizing radiation that is emitted from an x-ray. So obviously dangers there in high quantities. It can cause cancer. And then finally we have our most energetic and highest frequency radiation in the form of gamma. That's got numerous uses as well. Normally sterilisation. That's of things like of food, medical equipment, that kind of stuff. It's got a huge use in astronomy. So built into or devices and different instruments built into telescopes so that we can see gamma radiation being given out from certain galaxies, that kind of thing. But then this is the most ionizing. So remember that ionizing means that it has the ability to change the configuration of your cells. So again, that could lead to something like cancer. Okay, so that's me now gone through all of the different portions of the EM spectrum. Hopefully you've done the same, but you will have expanded on them more than what I have. So for example, let's have a look at a poor one from me. From my microwave, have just put cooking. I would expect you to have way more notes on your microwave portion of the EM spectrum. And that's given us a really great insight into the EM spectrum, but there is more that we can do here as well. Okay, so this is kind of the opening up of our topic on waves. At this point, I would also start to remember about the fact that actually the EM spectrum, all portions of radiation in the EM spectrum all travel at the same speed in a vacuum. Okay, so I'm just going to make this in a separate little box up here, just some more key facts. All waves travel at the same speed, and that is the speed of light, which is 3 times 10 to the 8 meters per second, or it's 3 followed by 8 zeros meters per second, if you want to see that number written down. So that's how fast every single one of those waves travels at in a vacuum. I also remember that I have reflection and refraction are properties of EM spectrum. Okay, so those two things will occur to every single one of those wavelengths, every single one of those radiation in the EM spectrum. So that's the kind of thing that I'm thinking about, okay? Now there could be that you have more information on your sheet, and it could be that you have far less. If you've got far less and you've paused the video and you've managed to go through, and this is you now checking back in, have a look back through the video and see where I've added and why I've added bits of information. if you've got more, really, really well done. That is going to set you up really, really well for when it comes to the little knowledge quiz that you're about to undertake, because it means that you'll have a really good grasp of what you've actually achieved during this topic. So that's it for now. This is what I'm showing you in terms of a goal-free task. At some point, whether it be in school or again in our distance learning lessons, I will give you another goal-free topic, but that time, next time that you see it, I probably won't do a video like this where I've stepped you through every single thought. I will just kind of let you loose. This is really your opportunity to show off everything that you know about any topic that we could give you these on. For now though, what you need to do is you need to go back to the document and click on the link for the little knowledge quiz. Complete the knowledge quiz. It should take you about 15 minutes to complete that knowledge quiz before you move on to section 2, which will be all about the reflection and refraction part of the course that we've looked at already. Okay, so good luck with your knowledge quizzes, and I will see you later.